At this year's Virtual ASCO 2020, Michael Long and his colleagues presented an update of the ZUMA-2 data, focusing a little bit more on the PK data, and really wanted to try and understand whether there were changes in the T cell subsets or cytokines according to whether patients had more aggressive disease or less aggressive disease. And they defined it by high proliferative rate, meaning a Ki-67 over 50% in this data set, or the presence of TP53 mutation. Interestingly, they didn't have TP53 mutation for all the patients. It was mutated in 6 and non-mutated in 30, and we're not really, and we don't really have the data for the others who were enrolled. Why do I mention that? You know, it's very likely that those who have elevated Ki-67s, particularly over 50%, also had a TP53 mutation. So there may be some overlap in these subgroups, number one. And number two, you know, because we didn't have P53 mutation data on a lot of those with proliferative disease, it's likely we missed it in a high number. And so, you know, it is interesting to see that there were some changes in terms of the percentages of effector or effector memory or naive T cells. You know, what that means in the grand scheme of things is a little bit harder to understand, you know, in this data set. One of the things that I really liked is their focus on clinical response. Here they focused on MRD. And so, you know, down to 1 in 100,000 cells, they had asked whether there were some cytokines that were more likely associated with a deeper response. And so, again, there were only 5 in the MRD negative population analyzed here, a testament to how well this works, but it also makes it hard to ask some of these questions. They could show that having a higher interleukin-2, interleukin-6, interferon gamma seemed to associate with a higher likelihood of being MRD negative. When we think about interleukin-6 and interleukin-2, these we think of as just being more broadly associated with T cell proliferation. You know, whether it's the CAR T cells or native T cells, as you know, Scott Roda's group from Harvard has been focusing on in the context of diffuse large B-cell lymphoma post-CAR, is a little bit harder to tease out, and actually may be very important when we talk about those with TP53 mutation who may have a lot of novel or neoantigens that they're expressing in the context of MHC. In any case, I was really glad that they did this, and you know, it'd be very interesting, you know, to see how this concept of now looking at the cytokines as a marker for MRD positivity or negativity, given its, you know, overwhelming sensitivity for detecting residual disease, can help us to better understand or predict who's going to do well or not do well over time. One of the other cool things they did in this particular update was to look at these cytokine signatures to see what they can predict for more severe neurotoxicity. Now, in this paper, they separated into those who had no neurotoxicity. There were about 25 folks from those who had very, very severe neurotoxicity, so grade 4 neurotoxicity, amongst which there were 6. You know, it shouldn't surprise folks that those who have severe neurotoxicity are likely to have higher cytokines, just as a general, you know, observation. But they could show this most clearly for interferon gamma, again, tumor necrosis factor alpha, MCP1, soluble VCAM1, IL-2, and IL-6. And, you know, of all of these, you know, the one that really gets my attention the most, of course, is interleukin-6. You know, we know that treating with tocilizumab for severe neurotoxicity really doesn't come with a lot of benefit. In fact, we really focus on the management of those patients with steroids. But why it may be relevant is there may be this secondary elevation of IL-6 that occurs as a consequence of tocilizumab. So we have seen in some studies that there's this correlation between having severe CRS and having severe neurotoxicity. And it may be that in trying to treat that severe CRS with tocilizumab, that we drove an interleukin-6 elevation that then, could potentially culminate in some neurotoxicity. Again, I don't want to make this sound definitive. This is pure speculation, and in particular in this trial, in many of the cases, the CRS and neurotoxicity were overlapping, which made it a little bit harder to tease out, to what extent concurrent or multiple doses of tocilizumab contributed to this sort of IL-6 rebound, we call it, or very high IL-6 that in turn may have been associated with neurotoxicity. So, overall, outstanding work by Kite, by Gilead, and was just fantastic to see Michael Wong, kind of present this updated data set. And I'm excited to see what else we're going to learn, from some of the correlative work that was done on this trial.